Today, I'm going to show how AccuKnox runtime workload protection protects the damn vulnerable workload application, also known as DVWA application. The main goal of DVWA application is to be an aid for the developers and DevSecOps folks to better understand the processes of securing applications. It provides an environment where security professionals can validate the security solutions and check whether the solution can effectively protect from the attacks. The DVWA application is installed on a Kubernetes cluster in DVWA namespace. It contains two primary components, DVWA web that interacts with the user and MySQL database. The DVWA application specifies multiple attack points and surfaces. The attack points are focused on web applications and typically involve attacks based on command injection, CSRF, SQL injection, CSP bypass, and several others. In this demo, we will look at how AccuKnox tooling can help protect from such attacks. AccuKnox tooling can help the developer or DevSecOps team understand the application behavior and subsequently create a least permissive policy that will constrain the application from multiple dimensions. Which are the processes that should be allowed to be forked? Which processes should be allowed to access the sensitive assets? Which processes should be allowed to use network primitives? The aim is to identify what application is allowed to do and deny everything else. This is one of the basic tenets of zero trust security. The two primary components at use here. One, QBarmer, that provides visibility for the application behavior and policy enforcement. And secondly, Discovery engine that consumes this visibility information from QBarmer and provides auto discovery of least permissive security posture. Let's see how the demo looks like. So as part of this demo, we have a Kubernetes cluster operating here. The QBarmer daemon set and the Discovery engine daemon set is already installed. The sample application DVWA is present here, as you can see. Let me log into the SaaS environment. This is the SaaS environment. I already have a login here. Let me sign in. Backend code is the workspace that I'm using. The first step is to onboard the clusters. The onboarding can be done through this procedure where you can onboard a cluster from any of the service provider. And then since I have already onboarded this cluster should show up in the cluster manager page. The cluster that I'm using is called Pandora cluster. And as you can see, all the pods and the corresponding workloads are shown as part of this cluster. The DVWA application and the namespace is shown here. Let's see how the application behavior for the DVWA web looks like. So as you can see, this shows all the network connections that have been attempted. It shows that the DVWA web pod is making an outbound access to DVWA MySQL service. Let's go into the details of which process is actually executing this, making this egress connection. As you can see from this information, Apache is the process which is making an outbound connection, egress TCP connection on port 3306 to DVWA MySQL service. On the ingress side, the connections that we have seen from the DVWA application from the user interfaces have been made, and those are essentially made to port number 80. This is a behavior from the network perspective. The same information is available from the process perspective. Like, you can see that Apache and Ping are the processes that are executed. Similarly, from the file observability perspective, these are all the different file accesses that have been made within the pod. The network observability information is available in the form of table as well. In the auto discard policies, you should be able to see the set of auto discard policies in the context of the namespace and the cluster. So these are all the policies that were auto discovered in the context of the cluster. You can see DVWA application, web, and MySQL. Let me go to the all policies section. So we already have a policy which is in inactive state here in the Pandora cluster in DVWA namespace, applicable on DVWA web workload. Now it's in inactive state, which means that it's not applied. Now if I convert this into active state, let me apply the policy. Now I have received a notification to approve the policy. You can go ahead and approve the policy. Let me approve the policy. The policy is now approved, which means that it is activated. And as you can see, the policy is now in active state. This means that we should be able to see the policy applied in the Kubernetes context. So we should be able to see that the Kubernetes policy is applied. Let's see that. Kubernetes security policies are implemented as Kubernetes resources. So as you can see here, that the policy that we had applied, activated, is shown here. If I try to kubectl exec into the DVWA application, essentially I should be able to execute only the commands which are whitelisted. For example, in the web application, there are just two commands. One is the ping. It should be possible to run ping, and it should be possible to run Apache 2, which is already in memory. But if I try to run any other command, for example, ps, it's permission denied, or grep or cat, it is permission denied. So essentially, nothing else outside of the whitelisted processes get shown. So in short, we have a least permissive security posture that is applied on the DVWA application such that if any processes outside of Apache 2 or ping gets executed, it is blocked. Now let's see how to view the logs operation, wherein if something gets blocked, we would like to know as to what was denied permission. There is a process. We had executed cat process that was denied execution. Then there is another process, grep, that was denied execution. So as you can see, all the logs that are present here are shown up in the context. Secondly, you might want to send the uh, information about these events to a notification channel. Here we can configure Slack or any other notification channel. Currently, I have Slack as the predefined channel. So to summarize, AccuKnox tooling helps protect the DVW application by understanding the application behavior and providing the way for users to see it, auto discovering the least permissive policy settings, and having an option to enforcing these policy settings such that the application operates in a constrained way. The application does only what it is supposed to do, and if it tries to do something else, we get alerts on policy violations. uh, Thank you very much.